as per our ritual, we will quickly begin with AI news this week. Allow me one quick minute to share that. First off, OpenAI has just, I think 20 hours ago, they announced their new feature connectors, which is very similar to Claude's or Cursor's MCP system. You can basically like connect your Gmail, your Drive, and a bunch of other apps to your ChatGPT, and you can do you can just jam with your GPT to do some deep analysis across your different sources. Now, this happened like 20 hours ago, and just this morning, then Dharmesh Shah, the CEO of HubSpot, posts on LinkedIn that HubSpot is the first CRM to be deeply connected with OpenAI's GPT. Now, HubSpot was also the first CRM to offer its MCP when the Claude's MCP wave happened. And once again, they've disrupted with this connector. It'll be awesome to see like how people are making their sales 10x faster, and even like bringing up like new use cases with such scenarios. Jamming with your GPT about like what is your latest email and like what are the top 3 trends in your email is still fine. But imagine having an AI secretary. Now, GenSpark has announced something which has bypassed OpenAI's connector system even more. Now you can just tell your agent, your GenSpark super agent, that hey, you know what, like based on like the team's availability in the emails, you can also like can you please go and create a schedule or a calendar where I can see everybody's availability. Over here, you can see the user has asked GenSpark to basically evaluate a resume that has appeared in his inbox. So essentially, like now, all of these like agentic tasks are also being done just by chatting with an interface. Last but not the least, latest research paper has come on self-improving AI. It's called Darwin-Godel model. So I'm sure like Alice from our team is sharing all of the links like associated to all of these news pieces in the meeting chat box as I'm talking about it. This model, this self-improving AI model, is essentially talking about how in a Darwinian fashion, AI models can also improve themselves. Now, a couple of days back in our WhatsApp community, we were chatting about how Google's co-founder Sergey is talking about how Gemini will be able to create its own version, and it won't take more than 3 or 4 years for us to get there. And like these are like real tangible things. We are moving in that direction. We have the kind of research to move in that direction, and there's really no coming back from here, which is why earlier today I had posted in the WhatsApp community that there's only 2 ways to look at AI now. Either you're a dinosaur who's looking at an asteroid that's coming in, or you're a surfer that's riding a very large wave. So with that spirit, everybody here, I'm sure, is a surfer that's riding this wave. And with that spirit, I will just hand this over to Aklant. Aklant, it'll be awesome if you can share your agentic workflow for building microservices.
Yes. Hi guys, it's Aklant here. So today's webinar is about AI first microservices. So before diving into the content of the webinar, let us just first discuss what the traditional approach is for building any new feature, or probably you get some feature requirements from your PMs, you will get the PRD, and then you are supposed to build and take it to production, right? So any traditional software development lifecycle includes from PRD, you get a bunch of devs, you explore a architecture for that feature, and then after the architecture is finalized, after jamming with a few dev people, you go into code generation, you write the test cases. But if speed is required, and if if the feature is very prioritized, then you probably compromise on the test cases, you leave it behind, you just focus on the code generation part, and then it is released it is deployed, and the customers use it. But next time onwards, if there is probably a minor change in that feature, or you want to build upon that, then because of this lack of test case generation, you will probably you will write the code, you will generate the code, but the diff, you don't know the diff. The area of impact is probably very high, and it will take your system down. So that is a problem if you prioritize space here. And oftentimes, if you prioritize space, then there is no boilerplate code. There is no coding standard which is being followed. So that becomes a major problem. Right. So in this AI first microservices architecture, I'll just take you through the whole pipeline as to how AI can help you get pace. It will generate test cases for your system, and it will ensure that the coding standards are followed throughout. So I started with this issue a couple of months back when I was working on a feature called as DA. So just to give you a brief, DA stands for Detect and Avoid Systems. So as FlytBase, we are a drone autonomy platform, and BVLOS is one of the waivers which is required to fly drones autonomously. But since the airspace is pretty much also used for other vehicles, such as there can be fixed wing rotary aircrafts or helicopters or other drones which can fly in your airspace. And if your drone is flying, then there is a possible risk that they might collide and your drone can crash. So that is a big risk for autonomous drones. So this DA system helps you integrate multiple sensors onto your system, and then based on these sensory inputs, you decide whether or not an intruder might be a threat to your drone. And if it is a threat, then you raise an alert so that the operator or any autonomous system can take necessary actions required. So the major problem here was we already had a system in place which used to look after all of this, but there were major problems with the system. The architecture of the system was not good. It was not scalable. In just a couple of drones, it used to crash and the CPU used to cross 100%. So it was facing high downtimes. There were integration issues because for every new sensor which we wanted to add to the platform, we had to write the code ourselves because there is no standardized input which goes into your system. Because of that, any new sensor, you have to write the code, and it easily takes 1 to 2 weeks to integrate any sensor. And because of all these architecture and coding issues, there was a maintenance burden. So the major task here was to revamp this system into proper decoupled microservices, which is built with pace using AI. And let me just show you a quick demo as to how this system looks like in production. Okay, so this is our dashboard, and currently there is a docking station placed, and there are multiple intruders which are flying over our airspace. And since these intruders are a possible threat to our drone operation, we are getting the required alerts. So here, as we can see, we are seeing an aircraft which is just 100 meters away, 141 meters away, and we are also showing its heading and what its threat ID is. So this gives a high-level perspective to the operator or any autonomous system as to whether the airspace is safe or not for current operations. So this is the current system, and this is the final product which is in production. Going back now to how we build this system. Okay, so as any developer would do right now. So when I started, I just used AI for generating the code. I got the PRD, and without putting any brain into it, I just directly went to AI and gave my PRD and asked it to generate the code. But that was the dumbest mistake of all. The code generated was pretty brittle. We couldn't write test cases upon it. Upon multiple sessions, the code, whatever coding patterns which we had decided for that system, it used to forget that. The AI which we use, it used to forget that thing. And for every session, I had to again, from ground up, train the AI to make it understand what is the exact repository structure, what is the coding pattern which needs to be followed. And the major thing was we already had a repository in place earlier. That repository had 10 to 12 microservices previously, and I was trying to fit these 3 microservices into that coexisting system. The major problem that was AI is a if you initialize an AI agent on your repository, then it learns based upon reference. So if there are existing flaws in your repository, if the coding standards are bad, there is no boilerplating, that there is no test case generation, then that it is highly likely that if you ask AI to build upon that code repository, then it will learn those patterns and it will follow those bad coding practices. And ultimately, you won't be satisfied with the code it is generating. So you may feel like that AI is still not up to the mark, but that is not the issue of the LLMs which you are using. It is issue of how the repository is structured. So upon realizing this, I finally took a step back and decided to use AI not just in code generation but in the complete software development lifecycle. So that was one of the major learnings here, not just to use AI in code gen, but the complete life cycle. We shouldn't just use it as a tool. It should be your dev team instead. So the jamming sessions which you do for architecture, it should be done with AI so that a final context document is generated, which is then passed on to other agents for building, testing, and then finally deploying. So the process which I followed for building these three microservices was firstly I got an PRD from my colleague. So he used GPT to research and then finally create the PRD. I consumed that PRD and I started looking upon possible architectures using Grok. So I don't know how many of you are aware, but Grok is pretty amazing when you want to do some critical thinking stuff. It might not be good at handling code directly, but for architectural decisions, or if you want some proper guidance as to how your architecture should look like, Grok is the way to go. I brainstormed with Grok as to what the possible architecture might be. I fed the inputs of the previous architecture, which had many failure points. And then probably after 3 or 4 hours of jamming with Grok, I finalized an architecture. Once the architecture is finalized, you get that document. And then for this thing, I did not leverage the existing repository. I created a new repository altogether because of the referential learning problem. I created a new repository from scratch. I gave the architecture document in a structured way to the LLM. So I use Windsurf for it. Then after multiple iterations, I finally figured out a way. I'll just show you in a couple of minutes as to what the proper template is required, which is through which the LLM can generate code fast. So I finally put it into a structured format as to what the product requirement is, what is the research we have done till now, what should be the API specs in the input and output of the system, and what is the current architecture, what are the probable coding patterns or task breakdown which should be done to achieve that architecture. So that was the part of my template. And after that is done, you go to code generation part. So you directly don't dive into code generation, but rather follow all the 3 steps mentioned here so that it is finally whatever task you get is palatable to AI. You can't just go and give a big task directly and expect it to generate code magically in 0 shot. You have to break down the task into multiple smaller achievable tasks for the LLM so that it can finally complete it. So after I had broken down the task, I gave it to the TDD test gen agent. So this agent is nothing but a Windsurf session which is fed with all the unit tests and TDD context as to how to generate test cases, how to write unit tests, what is TDD. So it is a session which is fed with all this knowledge. And once you give the structured context, it will start writing the test case initially. It will create a barebone structure of the repository, the service which you want to build. And as per TDD, it will first fail then it will write the source code, then it will again fail, and it will keep on doing it until all the test cases pass. So after you have generated your code and all the unit tests are passing, then I went on to create integration tests, which will test the complete data flow of your system. So this was the whole process which I followed to build microservices rapidly. Let's just do a quick hands-on as to what this process looks like actually before moving on to the learnings. Okay, so as you guys might see, I have Grok session open. So this is how I jammed with Grok to finalize the API specs and the architecture of the system. I won't dive deep into how to do that, but you can try out Grok for architecture. Then once the architecture is finalized, I'll just walk you through the steps which are required. So you just go on to Windsurf. Probably you start a new session. You start a new session, and as you can see, this is the current repository which we are following. Okay, so this repository has a completely different section for AI agents. So this, just to clarify it is not agent as such. It consists of all the knowledge base for AI agents to leverage. For example, there is a startup guide here in the AI agents folder. So this ensures that every time a new session is initialized in this Windsurf or Cloud Code, then the AI agent will just go through this startup guide and get the necessary knowledge as to what the current repository structure is. It will get that knowledge. It will also get some important documentation links which it should know. And probably if I ask it to create a service, or probably I ask it to generate some unit tests, then based on these documentation, it will refer to that. It will parse that document, it will get the knowledge, and it will implement accordingly so that it doesn't come up with a new pattern every time a new session is started. So this startup folder is pretty essential every time a new session is started. After that, the major thing is this prompts folder. So as you can see, there are multiple subfolders inside this prompt templates. So from code generation to testing to service creation, everything is templatized and stored here. So let me just open a few of the standard templates. So as you can see, this is the service creation template, which walks you through how a new microservice should be created. For Codegen, it is pretty important to name your documents like this in a structured format so that AI will parse it likewise. If you don't name it correctly, if these indexes are missing, then probably AI might directly go and fetch all of these things out of order. But it is important that if you want to probably form a correct chain of thought, then all of this system is structured. So it starts with how a new feature should be implemented in code generation guide. Then it goes into how it should break down tasks to make the implementation strategy. How to update a system for implementation statuses. So here it has broken down everything into multiple subtasks, which is palatable by the AI agents, and it is easy to achieve rather than just going and giving what the microservice should look like. You rather break it down into smaller palatable chunks. Then these are some standard coding practices as to how a service should look like. How should the entry point should look like? What are the common design patterns that the service should have? How do you generate code? The TDD-based coding approach. Whatever interfaces you design, what is the principle behind that? And it is critical that in these documents you also include some relevant examples, because as per my previous understanding, it is quite referential. All the LLMs you use, it uses reference. So if you give proper and finally validated examples as to how the do's and don'ts for the AI agents, then it is pretty good. how it should log every single thing which you require in a microservice. It is there in this code generation guide. One thing which is critical is everything here is based on your repository. It shouldn't be some generalized knowledge. There can be tidbits of generalized knowledge, but everything else should be tailored as per your repository. So all of these things didn't come in a single shot. It will come over time. Once you start building your own repositories, and once you start building microservices, then eventually, based on your learnings as to what across sessions, what mistake AI is making, based on that, you can create this document and put it here, so that for a new session, it doesn't repeat the same mistake. So, okay, this is the major folder, AI agents, and then the second major thing in this repository is the docs folder. So it has complete breakdown of every microservice or feature which you want to build. For example, the first microservice which I built here was named as core Airspace Threat Processor. So as I was explaining previously, that once you get the architecture doc, you just start a session in Windsurf, you type in the window, you give it, refer the architectural doc, and ask it to break it down into these sections. So for example, for a service, the first section can be of product, as to what is the exact requirement of this thing. There can be a research section which analyzes the problem and gives you the details. There can be an algorithm section which will refer to multiple algorithms which is required to be tried in this architecture. The API specs is critical to determine the input and output of your service. Then comes the architecture, as to what architecture is being followed in this service. Then there are implementation details about the specific algorithm you want to implement. What all things do you require for handling load for it? So all of these things should come in the implementation detail section. And then finally, there is an implementation status, which every iteration you do over this microservice, it is critical to maintain the history, so that you exactly know as to per iteration what changed. So this versioning is important. Okay, so let me just go back to what were the learnings during this journey. Okay, so the biggest learning was, if you are feeling like the AI, if you are using it in your current repository and it is learning all the bad practices, because of AI, now it doesn't cost you much to actually start from a clean slate. It is a better idea, in fact, instead of just scratching your head trying to figure out what went wrong in the existing repository. It is better to just start from scratch. So a clean repository with predefined boilerplates and coding standards is a pretty good idea. If you want to ensure that the output is consistent across sessions and across agents, then clean repository is one of my biggest learning. Then it is structured context. Everything you give to an AI, if you want similar outputs across sessions, then the input to that system should be standardized. It can't be like every time you come up with a new template to probably build something. So even when you are building microservices, it is essential to have a boilerplating there. And you, every time you want to create a service, just refer to that boilerplate, ask your AI agent or any LLM which you are using to refer to that boilerplate. Third major learning was to not just use AI in code generation, but rather the whole software development lifecycle. You should treat it as your dev team. Even for architectural discussions, you should brainstorm with it. Okay, so that's pretty much it from my side.
Awesome. Thank you so much, Aklant. I think we have a couple of questions in the chat box. So Sachin has asked, can you share the files? Are those on GitHub, or can you create a gist and share it on the Slack community? So Sachin, Aklant will be sharing the zip files on our WhatsApp community. I'm just going to be sharing a quick link for you to join the community.
Hey, I had a question. If we're in the process of starting out from close to zero today, I think we have like in our production repo, we have maybe one or two files. We also have a mono repo structure. What's a good starting point for building something like this out? So if we want, what if I saw multiple folders of documentation and practices built in, if we just had to pick the most impactful ones from these two as a starting point, where should we start?
Um, uh, I think you should start with boilerplating. If you have a mono repo structure as of now and there are multiple services, then you should first start with a boilerplate of that microservice. So if you have a boilerplate, then and every time you probably, if you want to create a new service, you can just ask your AI to refer to that standardized structure so that it can build according to that and not just refer to any random probably coding standard present in a repository. So it is pretty important to have a boilerplate. And moreover, everything which you have seen here, it is not built in like just in a day. So it won't guarantee that if you just probably gather all the best coding practices, best TDD test generation or unit test generation guide and put it in a repo, then it would work. It is not like that. It is totally based upon, it is tailored to your use case. So if you are building probably a different kind of system, which is not real time as such, probably a different forte, then you have to build it day by day. Every time you learn something new and you figure out that the AI is making a mistake here repeatedly, then you probably create a document and put it in that AI agent folder so that next time if it is doing the same mistake to that. So it will come eventually step by step.
Got it. Thanks. And if once we write this down also as like a simple statement like use pattern XYZ, do you use AI to augment it as well?
Uh, it depends on the use case. So if it is unrequired, then I just don't augment it. But it is always, even if you are augmenting it, then it is pretty important to have proper examples of it. If you just write lines that this is a builder pattern and I want to build something upon that, then it won't probably do that because it doesn't understand what a builder pattern is. So you have to give it examples as to how, what are the do's and don'ts, and based on that it will give you good output.
And I think, Aklat, another question earlier that had come from Mayur uh, was, can your AI model or agent help in model VNV? And can it also help in impact analysis and traceability? Can you take that up?
For traceability as such, there is no structure in place. So it is just purely based on logs. So what we are doing right now is to completely track one data flow. We have added a term called as transaction ID. So the complete data flow in your system can be traced down by that transaction ID, which is generated upon receiving the input until that particular input is processed and it goes out of your system. So only that much is done till now, but there no traceability as such is done beyond this. We are looking forward to build such systems. So it is in our plan, but not currently implemented. And I couldn't understand your model. We can you just explain more about what that question is about?
In the meantime, I think Mayur, you can unmute yourself or explain this in the chat. In the meantime, Aklant, you can take up Christopher's question. He's asking, can you give it your requirements doc to start with?
Yes, you can, but okay, Mayur, you can go ahead.
Yeah, thanks. So when I was talking about VNV model, I mean, for any software development, I mean, nowadays a lot of products, come with so much of electronics and software embedded into it. Okay, so I mean, let me take a random example of an automotive like vehicle. Okay, so in automotive industry, people use a lot of ALM solutions, application lifecycle management solutions. Now they typically go through, the software development lifecycle, and they have to ensure that the verification and validation model is properly done. So there is a proper VNV model where you actually analyze the requirements, then you actually design the system. Further, you design various modules, you do a lot of coding around it, you do unit testing, you'll have to integrate that with the testing with your architecture design that you have done. You'll have to do complete system testing because you have also done system design earlier. And finally, you'll have to actually accept the test cases. So this is a complete VNV model. If you simply Google it, you will find that out. Okay. Well, this is a much broader concept that I'm talking about. But in the industry, what is happening is all this work is done manually today. Okay. But people are looking at how AI can be layered on top of this, and how a lot of work can be automated. Like initially, you started with the test case generation. So a lot of inquiries generally come up that how AI can actually help in analyzing the requirements and how it can further help in test case generation. Another use cases are that how natural language processing can be used so that the voice bots can be brought in place, and a user can simply give the requirements. The AI can understand that requirement and standardize that requirement using the NLP technology, and then after that standardization can further carry out the entire VNV process, and further can generate the test cases. So there are a lot of inquiries, there are a lot of use cases which are coming up. This all to actually increase the efficiency, okay, and at the same time bring in more accuracy. So this is where I'm coming from. Okay. Does that help you understand what I am trying to find out?
Yes. So to answer your question, see, as per my experience, if you directly just involve it in the coding section or code generation section, then probably the unit test, whatever integration test it might write, probably it won't be that good. It will randomly generate some test cases which are of no use. So that is a major problem. If on the other hand, if you completely involve it in the cycle from start to end, even from architecture, if it is even aware of your architecture as to what the whole system might look like, then yes, it generates pretty good test cases. So even the microservices which we built right now, everything from unit test to integration test was written by AI, though not fully automated, because there is still a human in the loop who needs to verify that it is generating correct test cases, and on a higher level they need to verify it. So it is helping right now, provided if you involve it in the complete life cycle and everything which you provide is in a structured way. So there might be some test cases which is probably tailored to just your product. So if you have such cases, then it is best to write it down and provide AI in a structured way, so that every time a new system is built, it ensures that these test cases, it is a bare minimum to actually include those test cases. And on top of that, based on what your application might be, it will generate different test cases. So that can be a good starting point.
Yeah, I understand. I mean, we are working on something that an application where we first train the model. Okay, because you cannot start random with anything, because AI needs to be trained with some model. Then you can use it for your requirement analysis, and then further down the cycle for generating the test cases. So I understand where you're coming from, but in this course of action, what we are also looking at is that how the AI agent can identify the impact analysis, and how it can trace where the design of the code elements of the entire model probably has gone wrong, or can help in understanding the dependencies. Probably it can help in some informed decisions, okay, before the test cases are generated. Okay, so at every step, how AI can actually help is something that I am trying to understand.
How about Mayur, since we are a little short on time, we are already like 8 minutes beyond. How about we take this conversation to our WhatsApp community? How about Aklant answers your question over there, and maybe like other devs here can also join in?
Yeah, perfectly fine.
Awesome. I think Christopher had also posted a question, but has that been answered as part of Mayur's answer, Christopher? Can you just give us a thumbs up in the chat? All right. Okay, he says yes. So I think with that, we are towards the wrap of today's session. I hope everybody has been able to learn something new from Aklant today. This is something truly exceptional that he has built. We are going to be posting the prompt templates and the repo templates that he has created in our WhatsApp community. So I'm sure like everybody already has joined. So Aklant, like please don't have any delay in sending this, because people are awaiting your templates. And guys, we are doing this every Thursday at FlytBase. We are sharing our AI playbook openly, because we believe that teaching is more important than gatekeeping right now. Join us in our WhatsApp community. Join us in our Thursday webinars. We are sharing our entire company is turning AI native. Our HR builds her own HRMS. Our designers ship UI as code, not in Figma. So all of these hacks are being shared, and we are building in public, and we are sharing as much as we can. So please do stay connected, and let's ride the AI wave together. Thank you so much for joining in. Bye-bye.